book review time. I've been recently reading the Programming Quantum Computers book from O'Reilly, and I have to say I have liked it a lot, despite the fact that I haven't read it all through to the end yet. The reason being that I've been skipping some of the chapters because I want to basically learn things about the Shor algorithm by myself, using other materials that I can actually publish on YouTube. But basically, I wanted to quickly review that, maybe even keep it under 5 minutes, 5 or 10 minutes, because I think that's a book that every single person that's trying to get into quantum computing should get. At least read half of the book. So that's kind of the gist of my review, is basically telling you that. I mean, the cover says it all. It's essential algorithms and code samples. So don't let yourself be fooled by the programming here. I get the audience. The audience of this book is really actually, it's similar to what I'm trying to do with my channel, which is basically approach quantum computing without the mathematics. So just from an intuitive perspective. So the book does an awesome job. For the first half of the book does an awesome job, and it's really well structured, because the book basically, of course, I'm not going to show you I'm not going to show you the contents of the book, but I'll walk you through the basically, because I think you should buy the book if you really want to read it. I think it's only in the Kindle edition right now, so in the ebook form, but it's going to be in paperback soon. But basically, the idea is the book is super well structured because it starts from the lowest level. So it talks you through. Let me paint that a little bit. One qubit, then you go to multiple qubits, right? So that's good. And then basically, and actually, an important fact in here, you don't even see a damn gate matrix or any mathematics in here. At the end of the book, there's sort of a chapter called, let me see if I can find that. Let me just clear this out for you. There's at the end of the book, there's like a chapter that's called keeping staying on top. So this is for those who then want to dive into the mathematics. It gives you basically a really compact version of what the what the mathematics behind the basics of quantum computing, which is, it's, I think, pretty good. But it doesn't even, like, it barely mentions the block sphere, which I really like, because it here exactly. So okay, well, let me just go back one step back. So one qubit, two qubits, or multiple qubits, and then it basically talks. So it goes from the very basics of quantum computing to QPU primitives. So this is a second block. It's the block number 2 of the book, where they basically, by using the basic constructs in the first part, they explain how to build sort of higher level concepts, higher level primitives that come up and pop up in many algorithms that exist already. So it does an awesome introduction to quantum arithmetic. This was, for me, an eye-opening chapter, because this has basically helped me solidify my knowledge and my intuition on, the amplitude type of computation and the phase type of computation into something that it's actually what I basically had been juggling in my head to say, well, you can play with amplitudes, you can play with phases. And so here, basically, they give you sort of the basic recipes that allow you to make computations using your using the phase of your system, and also using the amplitudes of your system. So it's pretty cool. And then basically the book goes ahead talking about amplitude amplification. Here, maybe this one thing that I didn't like about the book is that the explanation they give of the amplitude amplification, it's the same that you find everywhere else, which is a geometrical thing with the averages of the amplitudes, which I think it is kind of, it kind of makes sense in hindsight, but it doesn't really intuitively explain what's going on there. I like to think a bit more about these being the actual positivity and negativity of your uncertainty that it's playing. So things are canceling out, and then I have an actual video on Grover's algorithm where I try to explain that without mathematics, and I think for me that was a much more clear intuition about how this works. And here they kind of stick to that classical geometrical explanation. The QFT I've read, and it's really awesome the way this is explained. But the rest, phase estimation, haven't read yet, and Shor's algorithm haven't read yet. And then it kind of jumps into QP applications. So that's the third block. So it's kind of three blocks: the very basics, then a bit of a higher level. Primitives, and then applications. In my opinion, the jump between block 2 and 3 is a bit too big. Um, in the sense that here we're getting into buzzword land. We're talking about like quantum machine learning and stuff like that. Um, but it's still, and also the chapter about real data and matrices, it was a bit sort of weird in terms of it was a weird way to introduce the concept of quantum simulation, I think. But at the end of the day, it's a book about algorithms. So really, that's what you should expect. Actually, block 3 makes up for almost the second half of the book, if I'm not wrong. And so I haven't really read about Shore yet, but basically, yeah, basically that's it. So I would definitely recommend at least you buy the book and read the half of it. This is definitely my advice to anyone that wants to get into quantum computing, and doesn't really want to dive into the maths that right away, because it's a bit scary, and it actually, I think this it's easy to drop the learning journey really quickly when you realize there's a lot of stuff that you have to swallow and sort of process mentally. I think that's a really good way to start, and it's done in a way. Okay, they the notation, the graphical notation they use to explain stuff, it's kind of good, but I think it's a good one. So they use like the so-called circle notation, where they show you the circularity of the phase, which is something that I've been talking in my non-mathematical introduction to quantum computing as well, in a way that is kind of nice. Um, so I like that. I like the fact that it's practical. I like the fact that it really has a bit of humor to it, but it's really practical. It's really like it helps you get started really quickly. Um, so I think if you combine that with exploring a bit and sort of a bit of self-exploration using the IBM Q experience, or which is my favorite one, or any other quantum computing interfaces that exist nowadays, I think that's the best thing you can do if you want to get into quantum computing. So definitely go and buy the book. I think it's a really well. I would say to date is probably the very best introduction for software developers and programmers. At least the first half, as I said. The second half is algorithms really. So it goes deep into how you optimize certain things here and there, and how you make tweaks that then you have to kind of bend your mind a little bit to accept that they make sense. But the first half of the book is perfect. Is really well written. So kudos to the authors for the amazing work here.